Hello everyone, I hope you are doing well. In the previous video, we learned about classes and instance variable. We learned how we can create instance variable and how we can create class variable. We also learned what is the difference between class variable and instance variable. Moreover, we saw how we can access them. We also saw how mutability factor affects them, like what happens if you make a class variable of mutable type and immutable type. There was one mistake at the end where I wrote this comment. It should be, instead of mutable, this should be immutable. Okay, use immutable type only for class variable. We know why it should be immutable, because if you use mutable, it will start changing for all the instance. If you change for one instance. Moreover, you can see there is a change in text editor we are using today. So we have earlier we are using a lightweight light excel text editor. Today we are back to VS Code, because I feel like we already now know all the syntax, most of the syntax that are required to learn Python. So now, to increase the efficiency, switch over to any modern text editor like VS Code, Atom, NeoVim, Helix, or any choice of your choice. Then, because this will increase your efficiency in writing code, and yeah, it also provides many of the other functionality, like it provides GitHub access and all of that. Okay, so for today's video, we'll be learning about some of the special methods that are used in Python class. We have learned some of them in the previous class, and when we introduced to class, right? So we have learned something like init. So we'll be learning some of them, like almost 10 of them today, and see how they differentiate and what are the purpose they serve in a class. Okay, so in a special method like this, right, they are also called Dunder method. It's called Dunder method because of the double underscore. You know that when you use init or something like that, we use the double underscore, right? Is double underscore before the name. That's why it's called Dunder method. It is just a short form of double underscore. Okay, so let's get started. First, we'll be learning about three of them. Okay, that we have already seen in our two classes, but we'll still recap it so that whoever is new can understand it. So we'll learn where init, str, then there is one new, but you'll find it familiar, called rapr. Okay, these are the first three. We'll be learning 10 of them, so these are the three. So these will be these are the first three we'll be learning for now. Okay, so let's create a class. So let's call a class called abc. Okay, so this is how we create a class, and if you can see, we have a error here, right? So this is a good part of modern text editor. So it will help you throughout you write code. It will say what is the error even before you run the code, right? It will show you all the errors that you're facing while writing the code. When you write syntax error, right, still it will show you that the syntax is not correct. If you see, stated must be separated by new line, so it's not identifying this as class. So it will help you out throughout. So switching to modern text editor for efficiency is a good way, since you now know all the basic syntax. Okay, so we know how to define a class. We write the class, then inside the class we can define methods, and for the first one we'll be defining this special method called def init. Okay, so how do you define? You write def and write underscore underscore init, then inside this you pass a parameter called self, and we have talked about self in the first class of classes. So if you are not familiar with classes, I will suggest that please go to our lectures 16 and 17 to learn classes. Then you come to this, because I will not be explaining all the concept of classes here, because we have already done that and it's waste some time. Okay, so we are defining this special function called def init. Then inside this, let's create one variable. Okay, so we'll create one attribute for this, for the object. We'll create its name, and let's put the name of let's code together. Okay, let's code together. So now what does this special function init does? So whenever you create an object of it, right, abc, suppose we'll create an abc object of it from the class abc. So this is how you create an object. So when you create an object and run this, right, while creating this instance of this class abc, right, this function will run automatically. You don't have to call it. If you define any other function, okay, like something like this, if run, and if you run this, and let's print out something, let's say print run. If you wanted to run this function, right, then you need to call from this instance. It will not run automatically. But if you write any function that uses this underscore method, right, and double underscore init method, this will run automatically. So to prove that, let's write here print init. Okay, now when you run this should not run automatically, but this should run automatically. Okay, let's run this now. So the python 18 and run. See, you see it's printed init, but it did not print run, right? So this function, right, init function is run automatically. So we'll run here, this function runs automatically while creating an instance or object from the class. Okay, so when we create an object or instance from this class, right, this is an object or instance abc, so this function which will run automatically. Okay, but this function, other function that is not defined using this init, this we have to run by ourselves. So if you want to run this, you can use instance dot run. Now both of them will get printed. If you run this, see, we get run and init. So if you want something to be run without calling it, right, then you can use this init function. This will run automatically. This is mainly used for setting variable. Okay, this is mainly used for setting variable or doing some initialization. So that's why it's called init. So in other if you go to other programming language, this is called constructor, but in Python this is called initialization, because everything we do here, right, is initializing the instance or initializing the variable, initializing some database or anything that you do before running any code, right? That is what you do here. That's why it's called init, and it's supposed to run automatically when you create an instance. So this is the init. Now there are two more special functions. One is called str. Okay, it's called def underscore underscore str underscore underscore. Then you pass the self. Then let's return something. Let's call it instance of abc. Okay, instance of class abc. So what is the use of this? So before, let's comment out this and show you what is the use of this, then we'll come to this. Okay, so suppose if you wanted to print this abc, what do you think will get printed? So if you have seen the previous class, you know what should get printed. So let's see what gets printed. So if you read Python 18 and run this, let me comment out this init. Okay, and run this once again. So you can see it will say main abc object at memory address, something like this, right? So if you want that it should not be coming this way, but it should be coming in some proper message, then you can use this str function. Now if you uncomment this and run this once again, okay, the same thing without updating anything. See, this time you won't be getting this, but you'll be getting instance of class abc. So if you want that when you print this instance, you want some special message for the user, then you can use this str function. Similarly, like this, there is also one called rapr. It's called representation and self. This also works same of how a string works. So let's see, return, I will write abc like this. Okay, and run this. If you run this now, you don't get anything, but let's comment this str. Okay, and run this once again. See, this time you got abc. So both of them look same. Okay, you don't, but they're used in different way. This is informal, this is not formal. Okay, not formal, and this is formal. So this is mainly used in debug. This is mainly used for debugger. So this is mainly used for debugger to know which class it's calling, and we don't represent like this. We don't put any text whatever we like. We try to keep it how the class should be declared, something like this. Okay, it's a representation of how this class is declared or something like that. But when you use this str, right, this is for the user to understand. So it's informal. We mainly write what the class is supposed to do. So this is mainly used for saying that user that is using. This is not for debugger. This is not formal of anything. We just say like what this classes will do, something like this. So that whenever the user prints this instance, right, at least they have an idea like what is this class supposed to do. So if you're using it for someone who is using the script, right, then you can use the str. But if you're using someone who is using the debugger or someone is trying to see the instance, then use the rapr. So use both of them. Okay, when you're writing class, use both of them. In the first one, keep it informal, that you think like someone else, your colleague is using this. But if you want that someone is using it to understand the code, then you can use the rapr, and this will print out in a more formal way of saying what this class is and how to be defined. Okay, so these are the three things we learn now. Now let's go to the second one we'll learn. So let me comment out this. Okay, the second one we'll learn is add. Then we'll learn about subtract. So these are arithmetic. Okay, so doing arithmetic. So why do we first, I'll go why we need this, then we'll be doing how we can add this. Okay, how we can use this. So first let's create one class called complex number. So if you are not familiar with complex number, let me show you an example. So a complex number is defined like this. Okay, it says real plus imaginary. So it's a imaginary number. So it's a combination of real and imaginary number. Okay, so in math it is defined like this. For user to understand, it's defined as a plus ib. Here a is the real part and b is the imaginary part. We use the letter I to suggest that this is a part of imaginary, and that's why we put an I here. Okay, so now if you wanted to add two numbers, suppose there is one more called c plus id. Okay, so when you add them, right, it will be something like this. It will be a plus c, then it will be an I plus I, then it will be b plus d. So this is how it will work if you add both of them. Suppose this is x equals to this, y equals to this. Okay, y equals to this, and x plus y will become something like this. X plus y will become something like this. Okay, so now we will be trying to do this using class. Okay, we'll be trying to do this using class, and we'll see how we can add both of them using class. Okay, I hope you got this concept of complex number. So let's create a class called complex number. We'll say complex number. Okay, then we'll define the init function. You know why we're defining init? Because we wanted to get the real and imaginary part. So we'll just diff init. Here we'll be taking two variable. Okay, self will be taking two variable called real and imaginary. We'll be taking two variable and we'll set them to real and imaginary. We'll say set real equals to real. So I hope you are understanding how we are writing this self and imaginary, right? So if you haven't, please watch the previous video where we talked about how we can use self and how we can define a variable. Okay, so now what this complex number will do, it will take an init, it will define two numbers. Okay, self, real and imaginary, then it will form a complex number because it has both the real and imaginary part. Now let's create one complex number, complex one. Okay, so we'll say complex number, then we'll pass here suppose 10, and imaginary will pass 5. Okay, so this is one. Let's create one more, complex 2. Here we'll pass 20 and here we'll pass 10. So what do you think the answer should be when we add them? So if you do something like complex 1 plus complex 2, so the addition how we saw before, right, it should be something like the real part of both of them should be added and the imaginary part of both of them should be added. But what happens when we do this? So suppose we put them in a result. Let's run this and see what it gives us. So let's clear out this and run this. See, this will throw an error. It says unsupported operand type plus for complex number. So it says that these are classes. This is not your simple complex number where you can add things, and just because you define real and imaginary, you can't add both of them. So this is the problem here, and to solve this we can use this special method add and subtract. So how do we do that? So let's add the add one, then we'll go with subtract. So you can define something called add. Okay, add, then you put self, and you know to add you need two number, and you know when you add self, one number is already coming, right? So you want the second one. So what you can do, let's say other. Now here what you can do, you can return complex number, and in the real part what you can do self dot real plus other dot real, and for the imaginary you can do self dot imaginary plus other dot imaginary. Okay, so now how will this work? So we said that we are defining a special function called add for an instance, and it will have one more variable, and we want to add the variable from both of them. So what we are doing here, let me increase this a bit. Yeah, so yes, something like this. So what we are doing, we are adding two things for the real and imaginary part. One we are adding from the instance, and the other one we are adding from the other number that complex number is coming. So here suppose there are two, okay, complex 1 and complex 2. What we are doing, we are passing so the first one, right, whichever we will be calling, this will be going as in self. Means this is the instance that the classes will know, and the the different one that you are passing, right, this will go as an other. So you know both of them has real and imaginary part like we defined here, right? This is the real for 1, this is the real for complex 2, and these are the imaginary for respective. So when we do this, it will add the real part and imaginary part like how we did here. Now let's run this once again. If you comment this, let's see, for the first time it was throwing error, right? But now when you run this, it did not throw any error. Why? Because we defined this special function. Now this class know that we can add two instances of this class. Because of this add, Python will understand that now it should not throw an error because we have defined something special here that will say that we can add two instances of this class. Now if you print this result, right? Print this result. This result, what you know? This is an instance, right? So this result should be an instance of class complex number. Let's run this once again. And see, it says complex number object. So now when you print the real and imaginary part of this result, right? So your result dot real and result dot imaginary and run this. See, now you get 30 and 15. Why? 20 plus 10 is 30, 10 plus 5 is 10. So this is what complex number is defined as, right? We define a plus c. So here a is 10, c is 20. So a plus c is 30. So we get 30. And here 5 is the b and 10 is the d. So 5 plus 10 is 15. So we get 15. So if you wanted to be in the real order, what we can do? We can put this in a f string. Let's put this in a f string, and so we'll say real plus I of imaginary. Let's put them in. So now it will be representing in a true complex number form. Now if you run this, see, we get 30 plus I15, or you can say 15i to make it look all the number in the left side and I in the right side. So run this, so you get 30 plus 15i. So now you see that we get this number, right? 30 plus 15i. So how does this work? So what it does is this complex number will be entering in self. The first one, right? This is the first one, first instance, this is the second instance. This first instance will enter as self, and the second instance will enter as other. So how can we verify that? So we know when we have learned about built-in methods in Python, we have learned about var as vars, right? So let's print the vars of real. So what this does, this prints all the variables that are part of this object. Okay, so we'll do vars of self, and then we'll do vars of others. Okay, vars of others. Let's do this. Now let's run this. You see, first it will say 10 and 5. The first one, this is self, right? So 10 and 5, this enters as self, and 20 and 10. Here you see 20 and 10, this will enter as other. So the first instance that you will pass, right, this will enter as self, and the second that you will pass, it will enter as other. But what if we do 3 times? So instead of complex 2, we'll do complex 3 also. Okay, so and this will take 30 and 15 as the real and imaginary part. Now if you run this, let's add this complex 3 also and run this once again. See, now you get 1, 2, 3, 4 times it prints the things, then you get the answer 60 plus. The answer is correct, 60 plus 30i. But how does it work? So how it works is, first this will become self. Okay, let me write in the top. First this will become self, this will become self, this will become other. Okay, then it will add both of them. After adding, then this will become the self. So let me put an plus here, plus, and this will become the self, and this will become the other. So this is how it works. The first instance will enter as self, that's why you get 10 and 5 here. If you see 10 and 5, and the second number will enter as other, and in the other you see you get 20 and 10. And for the second time, this total right here, this 30 plus 15i will enter as self. If you see 30 and 15 enters as self, and the last one will enter as the other, that is 30 and 15 once again, and that's why you get the answer 60 plus 30i. So this is how it works. So this add function will give you access that you can add any number of instance, and you can just add them like this. Okay, so that is how add works. Similarly, you can do for sub. So you can do sub, and one thing to be careful is here, we need to tell what this add will do. Okay, it's not like just because we named it complex number, Python understand how to add up complex number like this. We have to define like what we wanted to do. Okay, so let's make this more easier to read, and we'll pass something like this. So we'll say real equals to this, and imaginary equals to this one. Okay, so that you understand this in a better way. And here we'll pass us real and imaginary, real and imaginary. Okay, and this we have used to print. So this prints all the variable in the object. Okay, this we printed just to verify that everything is working. So now this look more cleaner. So as I was saying, add will not say how to add complex number. You have to define like how this complex number should be passed, and in the return you have to pass one more of an instance of complex number. Okay, now let's do for sub. So sub is for subtraction. Okay, and here also same thing, you do self and other, self and other. And what we wanted to do, we also wanted to do the same thing here. So we'll just copy this and put it here, just that here it is not addition, it's subtraction. So similarly like this, and instead of this we'll do something like result equals to complex 1 minus complex 2. Okay, and we should get this answer. Let's run this. See, you get the answer as minus 10 minus 5y, because this is real, right? 10 minus 20 is minus 10, 5 minus 10 is minus 5, and you get the answer in this way. So this way, there are two other arithmetic that we can do. Similarly, like add and subtraction, right? You can do something called multiplication and flow division and all that. There are many of this. Please look on this how we can do other arithmetic using this methods like this. Okay, so this was about add and subtraction using this special method. Now let's come to one more special method, that is len. So you have seen like when we use a list, right, and we use the len properties. So let me give an example. X equals to 1 2 3 4 5, and we can do something like this, right? Print len of x, and this will give you the what is the length of it. So if you run this, it gives length of 5. So how does this len work? So to make this work, this also uses a special function. This list uses a special function. You know, this list is a class, right? So this class also has an object, something like what we'll be learning now, that will give an access to this len property. So this is called len. Okay, and how do you do that? Let's see. Let's create an example. Let's say class mylist. Okay, and we'll define an init, def init. Inside the init, we'll create one list. Okay, so we'll say self dot let's create a list called named words. Okay, and here let's create one more called add. What will this do? This will add words. So word. Okay, and we can do self dot words dot append. We will append this word. Now if you wanted to know the length, okay, let's see here now. Now we know what this classes is meant to do, right? This classes will have only one instance, only one attribute called words, and it will have a function called add that will append the word. So let's create an instance of it. So I'll say list1 equals to my list. Okay, then now if you print this list1, what should be? You should get an object of my list, right? And let's append something. So we'll say list1 dot add. Let's put some word like hello, and if you want multiple, we'll call multiple time hello, there, and this. Okay, now if you run this once again, it will still fill the same thing, but if you wanted to get the length of this list, so how do you get that? So there are two ways to get it. One, we know that there is an list inside it, so we can get the length of that list. So we can do something like this. We can do print len, then we'll say list1 dot words, right? And if you run this now, so if you run this, we'll be getting 3. Why? Because we added 3 words. But we don't want to go this far, right? Because we know this list, this is a list, it won't be anything else. We have defined this is our custom list, and we wanted to use the property directly on this instance itself. So you wanted to do something like this, len of list1. You wanted to get the length of the list because we know inside this class there will be only one attribute or only one characteristic, that is words, and that is of type list. So we should be getting directly the len from the instance itself. But if you run this, it will say object of type mylist has no len. So it does not have this function. To add this function, then you can use this. You can use def underscore underscore len and put the self keyword, and here you can return len of self dot words. Now if you run this, see, it gives you 3 like it used to give before. So that is the use of this keyword called len. So if you wanted to create a custom list and you wanted to get the number of words that is included, and you don't want to access this way, then you can use this len function by just declaring one more function inside the list called len, and you'll get access to this. So this is how you use the len function. I hope you understood this special function called len, and when we use it, so you can use for anything else. Okay, suppose getting the length of, suppose here we have defined many characteristics, but you know that when you do the len function, you want to get of something, certain specific thing, then you can return any length of any words or anything like that. Okay, so that is how you use the len function. Now let's comment out this and let's go to one more, and this is the important one. Okay, so when we learned about for loop, right, then we learn something of this, right, like this, for I in range 10, right, and we did print I, and what did we get? We get all the number 0 up to 9 excluding the number that we write here. So if you run this, see, we get all of this. But how does this range work? So now we'll be learning how to create this range from our side. So we don't want to use this range because we don't know how this is working, so we'll be creating one of our own. So let's try to see how this range works. To do this, you should understand how this range work. Okay, so means I already explained while learning on range, but still let me say, so this range works, it has a start and end point. Here if you don't pass anything after 10, so this becomes the end point, and the start is always 0, okay, by default. And this is like an iteration, this is an iterable. That means it can be iterated. That means we can go element of element. When we reach the last element, it raises an error called stop iteration. That is how this loop ends. So the for loop takes care of this. We don't have to see on this. So how do you create a range of your own? So for learning this, you need to know two types of special function. One is called iter and one is called next. When we talked about special function, right, do you remember we talked about iter function and we talked about next function, right? So this function can be used when these two properties, these two special functions are defined inside a class. So today we'll be learning how we can use these two functions by defining these two special function inside a class. Okay, so let's create one class called myRange. So we'll be defining our own type of range. We won't be using this function that Python provide by default. We'll be using our own class called myRange. Okay, here we know what we need. We need the start and end position. So we'll create an init, and we'll say we need a start and end. So we'll say start and end. Okay, we'll say start and end. Then we'll say self dot start is equals to start and self dot end is equals to end. Okay, so now what we said, we'll create an init function that will have two properties, start and end. So now we have start and end. So start will go into self dot start and end will go into self dot end. Now if you run this, so let's create one. We'll create a function called range1, and we'll say myRange, and we know we need to pass to start and end. So we'll say start at 0 and go up to 10. So what is this supposed to work? This will be supposed to work in our for loop, right? So we'll say for I in range 1 print I. So this is supposed to be our goal, right? So what we wanted to do, we wanted to replace this range. So we want to make something like this. Now let's run this. We'll get an error. My range object is not iterable. So it says iterable. First we need to make is iterable. So to make anything iterable, what you can do, you can just call a function called iter and self. Okay, now let's return the self here. Return self. What will this tell? This will tell this class that this self, the object here, the instance created is an iterable. As simple as that. We don't know it's a list or anything, but for now we understand that this is of type iterable. So if you wanted to see, let's run this once again. See, this time it did not say it's not iterable. Why? Because we define this object or this special function called iter, right? So this will tell this class that this is an iterable. So now it will not throw this error that is not iterable, but it will throw something else error. Return non-iterator of type myRange, but it became iterable. Okay, the class, the instance, the for loop understood that this is iterable, but I can't find any instance in it. I can't find any number inside it. How do I go on? Means how do I see the elements? I can't find any elements. So for that it needs one more function that we saw, right? We need the next function. So what will this do? This will help in going from one number to other. And now we'll be defining what all these numbers are. So the first number, we know when we declare range, the first number is always 0. That means it has to start from 0 or it has to start from start. So what we'll do, we'll say if start is less than end. Okay, because we know it cannot go up to end, we'll return the start. We'll return start. Okay, so here start will not be defined because we need to use the self keyword, because self will tell this is for this instance, right? So now what will happen? Now when you call this next, means when you start looking instance, right, then it will say okay, we have self.start, then it will go up to this. But what happens if you run this now? Let's run this and see, it starts printing 0 and it's going on. It's an infinite loop. Let's cancel this. But why does this happen? So this happened because when we go in a for loop, right, it starts calling next, and here we are saying if self.start is less than self.end, just return self.start. So you know 0 is less than 10, right? So it will always be true. It is always returning 0. But we don't want to return always 0, right? We want to return 0 up to that end. So what we do, before sending, we'll do self.start plus equal 1. We'll increase the number by 1, but we'll be sending negative of 1. I hope you got that, why we did this. Okay, now you know why we did here plus 1 and here we send minus 1, because first we want to increase it, because after return you can't write anything, right? Because if once it's returned, it's gone. So we don't want to return directly. So we increase by 1. So for now I start become 1, but we are sending I equals to 0, start equals to 0. Now let's run this once again. Python 18 and run this. See, it starts printing none, and let's cancel this once again. So why does it print none? Actually it is not printing none, it's going way above. So we know that it needs to end at the end, right? So you say self.start is less than 10. So at one time when it comes to 10, 10 is less than 10 is false, right? So it will go to the else case, because we don't have any else case. So it will start returning none for it. So what we can do, we can put in the else case. We can say when it reaches the end, we know that in a for loop, how to know that iteration ended. So we can use one exception called stop iteration. We've learned when we are running range also, we have said, right, when we go in a range using for loop, right, the for loop understands that this is the end by using an exception called stop iteration. So what we can do, we can raise an exception. We can say stop iteration. So this is an exception that when you use in a for loop, that the iterables, right, they understand that if this is an end of a list or end of an iteration, then there is an exception called stop iteration that will say the for loop to not go anyone forward. Because if it starts going forward, it will start printing none. Okay. So now if you run this once again, see, this time it printed 0 up to 9. So this is what range was printing, right? So let me print the range also before this and run this once again. See, for the range printed 0 up to 9, then we printed from our own custom range 0 up to 9. Let me comment out this part. And run this once again. So we are getting 0 up to 9. So now you can see we have created our own range function, and we have understood how range in the inside, right, how the interior of a range may look if it's written in Python by us. So first we did the iter function, because the iter function will say that any instance created from this class, right, is an iterable. so that we can use inside for loops, so that we can iterate over them. And for iteration, it looks for a function called next, so that we can go to the next element. So we define one more special function called next, and this will give access to the next function. So when we learned about built-in function, right, we learned about next, right? So we can use the next here. So if I write print next of range 1, you should be getting 0 here. Say you get the 0. So it's just iteration. It forms like an object, right? Like how we learned about generator, it can keep on going. If you print the next, right? Like 1 second, now it will print 0 and 1. So you get 0 and 1. So this for loop starts calling this next function, and it prints all the number up to where the case became false, and we raise an stop iteration exception. So those are two more special function, iter and next. I hope you understood this. Now you might be wondering what are some more. So I'll tell two more of them. Okay. So we have learned about dictionary, right? So now we'll try to see how we can create dictionary of our own. So we'll creating one dictionary, and we'll learn two more special function in that part. Okay. So now we'll learn about two more special part. One is called get item. Okay. One will call get item. Not like this. It's a get item. And one more is set item. Set item. So before doing this, let me show you how this works actually. So when you define a dictionary, right? Suppose we'll say dictionary 1. Say dictionary 1. And suppose it says 1 and we call it 1. Okay. So how this works is, now if you wanted to get this one, right? So you can do something like this, right? Print dictionary 1 and something like this, right? And if you see, we get 1. And if you wanted to set something once else, right? So you can do dict 1. And if you do 2 equals to 2. And if you print this now, print dictionary 1 and run this, so you get this. First you print the 1, then second time because you set two things, then you get this 2 of it. Now this is if you see, this is using get item, and this is using set item. So now if you wanted to create our dictionary, right, then we can use this get and set item to make us behave like this. If you want them to behave like this, right, where you can use the square braces and put some number to get something, and put a square braces and assign something else in it to get this, right, there you can use this get and set item. So let's create one, then we'll understand this in better way. So suppose you think, let's create one dictionary called my dictionary. Okay, class my dictionary. We are all naming this my, so that we understand that how we can create our own. If you wanted in just in Python using, yes, we can't create the internals writing in C or C++, so that it becomes more efficient. But what we have already have, right, just using them and just modifying how they work, then we can create our own. Though inside will already be working, will be inside my. So when we work with this, right, when we work with the len property, inside we have used a list, and we know list already has an len property. So we're not actually creating another type of list. We are just trying to modify based on our instance of how we can use them and how we can use the len property in our instance. We're not trying to make a new type of list. Okay, we're just trying to modify the already consisting list. So here also, when I use my dictionary, right, you see, I'll create one init function. Here I will pass one variable called self dot, let's make it numbers. Okay, numbers equals to dictionary. So this is defining a dictionary, right? So now let's run this. So we'll create one instance of a dictionary 1 equals to my dictionary. Okay, let's run this and let's print this my dictionary. Okay, print dict1 and run this. See, you'll be getting object relation. Now if you wanted to add some number inside these numbers, yes, you can add them by doing this, right? dict1 dot numbers, then you can put something like 1 and call this 1. Now if you want to print them, you can do print dict1 dot numbers like this, right, and run this. So you'll be getting this one. But we don't want to do it, we don't want like how we used in len, right? We don't want to go up to that. Can we do something like this? We do dict1 and directly put 1 here and put the number. We wanted this to do, but if you see this will throw an error because it does not support this item assignment. It does not support it, but we wanted to do this. So if you wanted to do something like this, what we can do, we can create some special function. First, let's define set item. Okay. Now this will work how this works. Okay, we are assigned to set this variable and we are assigned to put this key, right? So we'll put here self, we'll put the key and we'll put the value. Okay, so this will need two more property, okay, key and value, because we know this is the key part, right, and this is the value part, so we'll need both of them. So now what we can do, we can do something like this. So we'll say self dot numbers, and here we'll put the key. We'll say key equals value. So what this will do, this will take the internal dictionary that we have defined and it will put the key and it will put the value here. Now what this will help us in achieving, if you run this once again, right, you should not see the error. If you see, we see no error. The previous one we saw this error, right, but this time we saw no error. Why? Because now this is valid. The one you are doing like this, right, now you can do similarly like this and this will add to the dictionary. So if I print this once again, okay, and let's call this, see, you get 1. So this is working. So this is how you can just set item. Let's do one thing. Let's create one function, str function, str, so that we don't have to write dictionary 1.numbers. Okay, we can just print it and it will print everything. So self, and return it from here also. We'll do return, let's return self.number, so not print it, because if you'll print it, it will print 2 times, right? So we'll just return it, we'll print it here. Okay, now if you run this, you see it throws an error. It says string return non-string type dictionary, so it does not support sending dictionary. So what we can do is simple, just put an f string here and convert this to a string, right? It's as simple as this. Now if you run this, see, now you print this dictionary directly, you don't have to even write. It's printing 2 times because we are doing here. Now we don't have to write this dictionary.numbers to get this. We can directly call this, it will just print the dictionary because we have a string function. This is one way of setting. Now how do you get this? But if you do something like this, right, dictionary and you do 1 and run this, see, this will throw an error because it's not subscriptable. We have used set item, but we haven't used this get item. To get an item, we can use the same thing. Let's put it here. This time we don't need all of them because we are just putting the key, and here we'll say instead of set item it's GET-ITEM, get item. Okay, and here we are return self dot numbers and the key. Now let's run this. See, this time we did not get the error, but we got 1 because that is what we set the item, right? So that is about get item and set item. I hope you understood. So here also we are not changing, we are not creating a new type of dictionary, we are just modifying the already existing one. We are just making that this object will behave like a dictionary, how we can add things, how we can put other things. And since internally it's a dictionary, right, so it won't allow any same keys to change, it will just keep on updating. So that was it about set item and get item. And yeah, that is all the special function that I want to talk about. We have talked most of it. There are many, okay, there are many, but we won't need all of them. These are some of the things that we need. Let me recap once again so that we can know whatever we learn today. So this is a special type of function. It's called Dunder method or special method. We call it Dunder because it starts and ends with double underscore. Okay, so first we learned about these 3: init, str and representation. So let me uncomment this so that we can see them once again. And what are the use? So we use the init when we wanted to initialize something. So when we create an instance of this ABC, right, so this function will run automatically and will create a characteristic named self or an attribute named self and put this string in it. Okay, then we have the str and repr. Both of them, when you print the instance, will return you this string and you can print this string. but they serve different purpose. This is informal way of saying this, and this is formal way. This is mostly used for debugger and all of this, and this is used for the user that are using it. Then we learned about some arithmetic way. So we took an example of how complex number works, and we created our own class that does all the complex number things for us. So we can add, we can subtract, right? So let me uncomment this also. So how we added two functions called add and sub. So how this works is, whenever you take two number, when you want to add two number, the first number is taken as self and the second number is taken as other, or any variable that you name here. And if you wanted to see what are the variable, then you can use the vars function and print it, so you can see what is coming when you are in the self, what is coming in the other. So we have used for plus and minus, and there is some more like flow, division, multiplication, all of them. You can just hack upon them and see how it works, and if you are facing any difficulties, you can comment out in comment section. Then we have used the len function. We saw that when we compare a list, right, we can get the length of this list using the len function. How can you define of our own? We saw if you use anything like an underscore len function, then we can use this len keyword, and we have shown with an example where we modified how a list does, and we can now use the len function in our instance itself. We don't have to go inside the list like how we went here. We can go directly on our instance. Then we saw how we can create our range function. We talked about range when we learned about for loop, but here we modified our own. We created our own range here. Actually, we did not use the range function. We have used iteration and the next function to create our own range, and it can print however this range function prints by the default that Python provides. Then at the end, we have learned about get and set item. These are used in dictionary. So we have created our own dictionary called my dictionary, and we have used the set item and get item. The main purpose of this is how we can add a number, how we can assign a number using the square braces and without using the dot operator and going to the dictionary then adding them. So these are some of the simple and most used Dunder method or special method in class. I hope you got the concept clearly, and if you are facing any difficulty, please comment out. I'll try to solve them, or you can join our Telegram discussion group and we can discuss there. So let's post this to GitHub then. So we'll do git status. So these are the two changes. So we'll do git add all. We'll do git commit. And today we learned about special or Dunder methods. Okay, so it was special, or it's also called Dunder method. What did I write here? Special. Okay, and to git push origin main. So it throws an error. It says I think I did some change directly on GitHub, that's what I'm saying. So if you wanted to get all the changes that was done directly on GitHub, you want to bring them in your local, what you can do, you can use git pull. And if you do git pull, yes, so it says it's done. Now you can do git push origin main. Now everything should be going, because I made a change, I did not do the pull, that's why I had to do git pull. Now it configured everything on my local and I pushed everything from there. Let's click on this, and today's our 18th lecture. So let's see if it got pushed to 18th. Let it load for a while and go to 18th special methods. And yeah, we have all the methods here. So yeah, that was it for today. So the new things today was we have introduced with GitHub. I mean, not GitHub, it's VS Code. So VS Code. So this is a modern text editor. You can use it. Okay, you see, it's very efficient. And I'll show you one thing. Okay, so when we write the init function, right, we don't have to write this function by ourselves. If I write init, right, init, write def and ini, and just press the tab, see, it will fill up for me. So these are some of the special things that text editor can do. Okay, means which some modern text editor can do. So you can use them. It makes your work efficient. Though I'll not be using them so much extensively because we need to learn things. But yeah, getting used to some modern text editor makes your work for more easier to do. Yeah, that was it for today. I hope you understood all the concepts. If you are facing difficulties, please comment out. Okay, and yeah, thanks for watching. See you in the next.